Okay, I don't know what happened, but I couldn't see my little recording that I was actually recording. So I don't know. Must have clicked the wrong place. Okay, so what's important about blood flow? The blood in the arteries is in the highest pressure, but they have thick muscular walls that are going to help them kind of maybe even out the pressure so that it's not a big, huge increase and decrease. Okay, blood flow slows down in the capillaries. It's important that it slows down so that you can have gas exchange. Okay, it allows time for oxygen to move out, carbon dioxide to move in, nutrients to move out, waste to move in. Okay, and then blood flow in the veins is low. Okay, so let's just look at this line. Okay, so this is arteries. Okay, and then here's veins. Okay, so I just want you to get the idea that the blood pressure is much higher in the arteries, slows down in the capillaries, and is low in the veins. Okay, and this is speed. So it's moving through the arteries pretty fast, really slows down in the capillaries, and then it kind of picks back up in the veins. Okay, so if the pressure is so low in the veins, how does it get back to your heart? Okay, so in order to get the blood back to your heart, certain things have to happen. Okay, so we have valves. Valves are going to help prevent the blood from flowing backwards. Okay, but we also use two other systems to help the blood get back to our heart. So one is called skeletal muscle contraction. Okay, so here's a vein. Okay, and then here's skeletal muscle. So what happens whenever you walk around or bend your arm or just bend your leg? Okay, move any skeletal muscle. It squeezes the veins. Okay, when it squeezes the veins, it forces the blood to go back to your heart. Okay, when it relaxes, when those muscles relax, the blood gets stopped by the veins, so the blood can't go back. It's not like you're starting from your toes every time. Okay, when you breathe, the same kind of things happening with the muscles and the organs in your chest cavity. Okay, so it's going to help take blood back to your heart. So we call it the skeletal muscle pump and the respiratory pump. Okay, and the valves. All those are going to get blood back to your heart. If you think about somebody, if they faint, so think about like America's Funniest Home Videos or in the military, when people are standing at attention or graduation, something for a long time, and they stand still and they don't move their legs or anything. What happens is gravity works against us and all the blood pulls to the bottom of pulls to your legs. Okay, so it all pulls down. But your brain isn't getting enough oxygen, it isn't getting enough blood, and your blood pressure drops. So what happens is you faint. When you faint, you're flat. Okay, you're like this and gravity's working with you so you can get blood back to your brain again. So venous pooling, okay, is because you've stood still too long. Okay, now cardiovascular pathway. Okay, and we didn't talk. The book has all sorts of good connections and misconceptions, disorders. It's got all sorts of cool stuff in there. I'm just trying to kind of cover the big picture things in this PowerPoint. Okay, so the pulmonary circuit. So there's two pathways that the blood takes. One is called the pulmonary circuit. One is called the systemic circuit. Okay, so the pulmonary circuit, it's the right side of the heart. So we're going to take the blood, okay, from the right atrium, okay, to the right ventricle, out to the lungs, pick up oxygen, okay, and then we're going to take blood back to the heart. Okay, so the right side of the heart is bringing its pulmonary circuit. So the deoxygenated blood comes back to the heart, goes to the lungs, picks up oxygen, and it's going to come back to the left side of the heart. So it's really just going to the lungs. The systemic circuit, okay, is taking blood all over your body. Okay, so systemic circuit is the right side of your heart. So the blood goes out the aorta, goes to your head, to your arms, goes to intestines, your kidneys, your liver, all of your body systemically. Okay, and then that's right side. Okay, so right side's taking oxygenated blood out. Left side is receiving deoxygenated, taking it to the lungs. Okay, so it's really that we have two pumps working. So the right side's doing one thing, left side's doing the other thing. And they have to be working at the same time, and they have to be working equally well. Okay, they have to stay in homeostasis. If the right side's working better than the left side, then fluid can accumulate in your lungs. If the right side's working better than the left side, fluid can accumulate systemically. Okay. All right, now the big arteries and the big veins. Okay, so systemic circulation. Wait a minute, I want to see. Okay, so remember that the path of blood, it's usually arteries, arterioles, venules, and veins. There are some major veins and arteries that you guys need to learn. Okay, so if we look, let's say, okay, so here's your heart, here's the aorta. We come off the aorta, we're going to go out this subclavian artery. There's also a subclavian vein that's going to bring blood back. Common carotids take blood to your brain. Jugular brings blood back from your brain to the heart. I'm not worried that, I guess you should know, like the renal vein goes to the kidneys. The aorta is the big vessel that's going to take blood out to your body. Okay, so that it's kind of divided into regions. So there's a thoracic aorta, there's an abdominal aorta. The aorta splits, and we have these iliacs, and the iliacs are what goes to our legs. There's femoral vein, which goes down alongside your femur, the big bone in your upper leg, and then there's this other vein that's called the great saphenous vein. Okay, the great saphenous vein, okay, is the longest vein in your body. It runs all the way up your leg. Okay. There's lots and lots of vessels. I just want you to know some big ones. Okay, so like no superior vena cava, no inferior vena cava, carotid, jugular, subclavian, femoral. I'll make a list for you. Okay, so coronary circulation is really important. Coronary and circulation, those are the arteries and the veins that are going to take the blood to the heart. Okay, the heart has to have blood. If it doesn't have blood, okay, you're going to have you're going to have a heart attack. I shouldn't laugh, but you'll have a heart attack. Okay, so these are the ones that they supply the heart with blood. Okay, there's another system that is a modification. This is called hepatic portal circulation. The hepatic is the liver. Okay, so really all this is, it takes blood from the organs in your digestive tract that has amino acids and glucose, and it takes them to the liver. Okay, so it's going to do two things. One is it's going to take the amino acids and make proteins that are important in our blood. It's going to take glucose, make glycogen, which is a way we store glucose. It's also going to remove the liver. It's also going to take the toxins out. Okay, so it'll detoxify the blood. Then we'll put the blood back into circulation. So it's important to know, okay, that the hepatic portal circulation, the whole point of it is to filter the blood from the digestive organs through the liver. Okay, so it's detoxifying. Okay. All right, now, how does exchange at the capillary beds take place? Okay, so the main way it takes place is due to the osmotic pressure of the blood and the hydrostatic pressure of the blood. So when the blood comes into the arteries, okay, the blood pressure is really high, and it's going to force things out into the tissue. Okay, so here's the arterial, here's the venule, here's the capillary, and the capillary is blood. Okay, so these are red blood cells, and there's other molecules in there. Okay, out here, this would be tissue. These would be cells. Okay, so at the artery end, things get dropped off. Okay, the osmotic pressure drops things off. At the venous end, okay, the pressure, the osmotic pressure, so there's more solutes in here. This is hypertonic, and it's going to actually pull things in to the blood vessel. So things are getting dropped off at the artery end, they're getting picked up at the venous end. Okay, another thing that goes on around the capillaries are these lymphatic vessels. So the lymph system is a closed end system. So it's not like arteries and veins. They only go in one direction. And their job, these lymphatic capillaries, they always make them look green in pictures. Okay, their job is to pick up extra fluid that might accumulate in between the tissues in the cells, around the cells. Okay, so they pick up the fluid, and eventually what they're going to do is they're going to drop it off at the back into the bloodstream at the heart. Okay, another thing that's on this slide is about these precapillary sphincters. So a sphincter is a round muscle that closes off an opening. So if your tissue's not active, there are little almost like valves. They're called precapillary sphincters. They shut down blood flow into here because technically you don't have enough blood in your body to fill up all your capillaries. Okay, so you don't have enough blood to do that. So you only send blood to tissue that needs it, so tissue that's metabolically active. So you can bypass these capillaries and not hurt anything. Okay, it's 12 minutes. I guess I should stop because the thing's getting too long. Then we'll talk about